Hello and welcome back. Today we'll be revisiting the irrational numbers. Now to do this revisiting of irrational numbers, one theorem you have to come across. It is theorem 1.3, you can see in your textbook. Let the theorem says like this: let P be a prime number if P divides A square, then P must divide A as well. If P divides A square, then P must divide A. It says like this, the theorem, where A is any positive number, where A is any positive number. So here what the theorem says is, if suppose this is P, it's a multiple of say K or any other number, then if 3 divides, suppose this is A square, let us take a square number, then I have to take it as 81, suppose 9 square, that is your A square. Then if 3 divides this 9 square, we all know that 81 can be divided by 3. Now in that case 3 must divide A as well. If you remove the square, 3 must be able to divide A as well. So if it can divide A square, then it can divide A as well. So that is a theorem that we are going to use while proving root 2, root 3, root 5, root 7 as irrational numbers. Now let us see how to prove root 5 as an irrational number. This method of proving we call it as contradiction method. First we'll assume that it is a rational number. After assuming it as a rational number, then we'll try to disprove it that it cannot be rational. And if it cannot be rational, then it must be surely an irrational number. Let us see how do we do this. First of all, you will assume like this. This is our assumption. Let root 5 is equal to P by Q, and it is a rational number. And rational number definition you already know. P and Q both are integers, and Q must not be equal to 0. And on top of that, one more thing you have to know, that P and Q both are co-primes, and P, or you can put here one comma, as well as P and Q are co-primes. Now what is a co-prime? That is necessary to know. If the HCF of two numbers it is 1, then the numbers are said to be co-prime. That means they can have a common factor, that is 1. Like suppose P by Q, when I am writing, then it will be like this, 2 by 3. They can have a common factor 1, but other than 1 they cannot have. Other than 1 they cannot have. 1 can have, because ultimately it will give you same thing. 1 to 2 is 2, and this 1 to 3 is 3. But if you want to put other than 1, then if I put here 2, and here also if I put 2, it will become 4. The number will change. 2 by 3 will change. 4 will become, and this one will become 2 3s are 6. So they cannot have like this common factors, but they can have common factor 1. That we call it as co-primes. The HCF of both number, if it is 1, then that number we call it as In numbers we call it as co-primes. Now this is our assumption. Now after doing this assumption, what you have to do is squaring on both sides. You will get here root 5 square will be 5 p square divided by q square. Or you will get like this, if you cross multiply, p square is equal to 5 q square. 5 into q square. Let us mark this equation number 1. Here your theorem 1.3 will come. Here you can see 5 divides p square. Or we can say the other way also, 5 is a factor of p square. So if 5 divides p square, then 5 must divide p as well. Or 5 is a factor of p as well. You can use any word which you like. It divides, or you can use it is a factor of either of the two you can use. Suppose I am using the word factor. So I write like this. Since 5 is a factor of, or you can write here, 5 is a factor of p square, therefore 5 is a factor of p as well. 5 will be factor of p as well, or you can write like this also, as I am telling you repeatedly. 5 is a 5 divides p square, therefore 5 divides p. That way also you can write down. After finding out the factor for p, what we have to do is this p we don't require anymore, so we'll try to replace it. How to replace it? Let p is equal to, you are doing for root 5, then you must take here 5. If you are doing for root 3, then you have to take 3. 3 times n, where n is a natural number. Now if you put the value of p in equation number 1, putting the value of p in equation 1, you will get p, it is 5n, it is squared, so I put squared, it is 5q squared, this one will remain as it is. 5 square is 25, n square equal to 5q square. Then this 5 you can bring on the other side, you can write like this, q square is equal to, this one I am taking first, 25n square divided by 5, 25n square divided by 5, 5 5s are 25. Like this you can show that 5 is a factor of q square as well, and if it is a factor of q square, it must be a factor of q. So here 5 is a factor of q square, therefore 5 is a factor of q. So what we found out is both this p and q have the same common factor. The common factors are 5 each. 5 is a factor of p as well as 5 is a factor of q. But here though we said that p and q are co-primes, or assumption. They can have only the common factor 1. But while calculating we got that they have common factor 5. So it contradicts, or it's against the assumption that we have taken. And our assumption is what? A rational number. So if it does not fit in, or if it contradicts our given assumption, that means if it cannot be a rational number, then surely it must be an irrational number. Like this we have to conclude it. Write down, since both p and q have the same common factor, is 5. This contradicts our assumption. Therefore, root 5 is irrational. So this way you can do for root 3, same steps you'll do, same writing will be there. Root 3 if you do, here 3 will come out. Then in this case, you'll take 3n. Then here also you'll get 3 as a factor of q. If you do for root 7, same way you'll do, here will come out 7q square, here it will be 7n, here it will be 7n square. So like this you can prove all the single root values in this format. Like root 2 you can do, root 3 you can do, root 7 you can do, root 8 you can do, root 11 you can do, anything that will be asked in the same format you can present it. And it's very important for exam purpose, so all of you will have to know. Let us do the second question now. To do this, to prove a rational number and an irrational number, when you either add it or you subtract it, the result will be irrational. You don't have to follow the same procedure that we have done in question number 1. The simple way you can do, let 3 plus 2 root 5. Here also assumption you will do the same way, equal to p by q, a rational number. This will be your first step. Then here you don't have to take any co-prime. There must be co-prime, no doubt, but here you don't have to pull that much long. What you'll have to do is, this rational part you separate from the irrational number. You can see very clearly that root 5 is irrational. So this rational part you try to bring this side. Here you can write 2 root 5 is equal to p by q minus 3. This will become 2 root 5 equal to p minus 3q divided by q. If you take LCM, or if you don't take LCM also it's okay. This is purely rational now. This is an integer, this is an integer, this is also an integer, and q is not equal to 0. So here what we did is, one part fully we kept irrational number and one part fully we kept rational number. And as we all know that a rational number can never be equal to irrational number, but we are writing here equal to, that means our assumption is not correct. This also contradicts our given assumption. That's why the number 3 plus 2 root 5 is an irrational number. Here you write like this. Here 2 root 5 is irrational, whereas p minus 3q by q is rational. Since a rational number cannot be equal to irrational number, this contradicts our assumption. This our assumption. Therefore, 3 plus 2 root 5 is irrational. Like this you can prove it. But here writings do it nicely, the meaning should come out clearly. It will carry around 2 marks. The earlier question will carry around 3 marks. So depending upon mark you have to present it. Let us see one by one in question number 3. Here also, like the second question, you will proceed. Let the first one we are doing, 1 by root 2 equal to p by q, and p by q a rational number. The moment you cross multiply here, q is equal to root 2p. This side became rational, only integer, and here it became irrational. So here also, like the earlier question, you write down, since a rational number cannot be equal to irrational number, of course here q is rational, whereas root 2p is irrational. Since a rational number cannot be equal to irrational number, our assumption is wrong, or this contradicts our assumption. Therefore, 1 by root 2 is irrational. In this way you can write down. The next one, that is the second one, 7 root 5. The same way you proceed. This is the second one. Let 7 root 5 equal to p by q, a rational number. Then here also, if you cross multiply, or you can do like this, root 5 you can keep it here, and p by 7q you can bring down. Then here p by 7q is rational, whereas root 5 is irrational. Root 5 is irrational. Since a rational number cannot be equal to irrational number, this contradicts our assumption. Therefore, you can write 7 root 5 is irrational. This way you can do. And then the third one, you do exactly the same as question number 2. With this, we have come to an end, revisiting our irrational numbers. Thank you and have a nice day.